Yeah, if you go to wordpress.rose.edu and look for last year's recording and the prior year and the prior year, they're all up there for this lecture. That way, you know, I don't know if you've compared some different years together, but sometimes I say it a little different, might explain it a little better. But I actually have a recording up there when Raymond taught it, the guy who actually wrote this. So there's many different versions of it up there, so please go back and look at them because I might explain it differently one year to another. Okay? It's on wordpress.rose.edu, find this class, and then you're good. Okay. Yeah, Raymond Hachette made this. Raymond was in the position that Roy's in now, but Raymond actually worked and produced stuff compared with Roy. Raymond currently works at an agency in D.C., begins with NSA. He actually solved some major encryption problem they had. Whatever it is, I don't know. But he solved it and actually got an award from some big higher up in the government. So he did good. And he created these slides, which you'll see are very detailed. Okay, let's talk about AES, Advanced Encryption Standard, or system. Okay, it's based on the Rigendale cipher. Now, do I actually have it in the folder here? No, I don't. But I actually have a little flash video that I'll post up there to see it as well, that walks through this, but this is all you really need. It's based on the Rigendale cipher. Damon Rigendale in 2000 became a fifth standard in 97. Oh, fifth standard in 2001, fifth standard 197. It says a system breaking DES in 1 second. You all know what DES is. Okay. A system that can break DES in 1 second would take 149 trillion years to break AES at its smallest key size. So what do you think? A little better? I mean, DES was confusing enough, but this is actually much better. Okay? Very good performance of both hardware and software. Okay? Works in all environments pretty much, and now it's standard in wireless routers and VPNs and pretty much everything. What's cool here is actually variable block and key lengths and number of cycles. Remember, DES was how many blocks? How big was the block? 64-bit. Very good. How many rounds? 16 rounds. 56-bit key. 8 bits for parity. Remember all that. It was all hard-coded. This is all variable. You can change the key length, change the rounds, change everything, which is kind of nice. It's very simple. Has low memory requirements. Sound design suitable for ATMs, pretty much everything. It's not based on secrecy, it's based on sound mathematics. Okay? Okay. Details says most ciphers are based on the Feistel structure. It says some of the bits are basically transposed, named after Horst Feistel. I don't know if I might have put a slide in there about him, I can't remember. Uses 3 distinct invertible information layers. Now, the algorithm itself has many steps. It's called SubBytes, ShiftRows, MixColumns, and then add round key. Okay? We're going to walk through each one of these in detail. And I'm going through and make sure you ask questions. Okay? Byte sub gives us diffusion, then we got confusion, then we got confusion and diffusion, and then confusion again. You should know what all of those mean. Okay? I did put these up just a few minutes ago. All right. It says resistant to all known attacks. Okay. So speed, code, compactness, wide range of platforms basically makes it good for pretty much everything. Very simple design, again, based on sound math. Rather than being based on secrecy, it's based on sound math. Okay. The number of rounds obviously can be changed. The verbal block size, key size, all can be changed. So a lot can be modified in this algorithm. Okay. Now, y'all remember this? From the DES assignment? And from, actually, I didn't make you do it on the test, but I made you do part of it on the test, okay? You need to know that, okay? So if I was to create a state for dog, D is 44. So D is 44, okay? O is 6F, 6F. Everybody see that? G is 6, 7, okay? Nothing new there. It's the same way as in DES. It pretty much works the same. Now, if you're writing a program to do this, like a Java program or something, there's literally modules that do all this automatically. You can do hex to DES, hex to int, double, whatever you want. It does it all It's built into Excel even. I don't know if anyone's messing with Excel. There's even methods inside of Excel to automatically convert this. Pretty basic stuff, but that's how it works. Okay? All right. Now, we need a cipher key, and I'm going to give you the key for your homework assignment. Okay? I give you a key. Okay? Just like in DES, we give you a key. Okay? Now, we have to take that key and create a round key. This is one of the very first steps. And actually, while I'm going through this, I'm going to bring up your homework so I can show you kind of where we're at. So everybody okay on the first part? I give you the word computerized 1357. You run it through the hex to get the state. Everybody okay with that? No problem. Okay? I give you the cipher key. Okay? And then you take the cipher key and run it through to you creating the round key. That's kind of where we're at in the presentation right now. Okay? Now you'll notice in this homework we gave you a couple answers. All of the answers in this spreadsheet are correct, or in this homework assignment. When it was first assigned, they weren't, but these are all correct. So don't freak out. Okay, so let's continue on here. Okay, so we're going to create a round key. Okay, so what you do is you take the last column. Our last column, 8A, 2261 in BE, becomes 2261 BE and 8A. Everybody see what happened? We rotated it up, okay? So the last column is rotated up, okay? Shift up, okay? So 8 goes to the bottom, everything else goes up, okay? Now, step 2. Now there's 2261, okay? See, so we created 2261 BE and 8A. See that? That's what we created. Now you run that through the S box, and that was on your homework assignment. I gave it to you. So how does this work? Well, let's look. We take the 22, we get a 93. 93 goes into there. So far, so good? Nothing difficult. Now we take 61. We take the 6 on the left, the 1 on the top, and that gives us EF. EF goes over there. So far, so good? Yes, hopefully. All 4 of you? 5 of you? Okay. BE, B, then E at the top, and that gives us AE. AE goes right there, and then 8A, we do the same thing. We get 7E. Again, I gave you the PowerPoint that has these animations in it, just so you can see where this stuff comes from. Okay?
So unlike the other little thing that we just did, I noticed that you had started from the top.
Right, this one we started on the left side, and then the top. So the BE, left is the B, the top is the E. Okay? Now, I will tell you, you must do a portion of this on the test. Any ideas which part it might be? It's the matrix, the most confusing part. So, when you get to that point, make sure you understand it. And I will tell you, I will help you on this, but you're going to have to start on it soon. Don't wait until, like I said, I'm gone Thanksgiving week. It's due the Sunday of that week, beginning of that week, but I'm still leaving the Saturday, so start on it early, get part of it done. I can check it multiple times. That's not an issue. Okay? All right. So we take these values. So we just created this 93 EF. See all that? Okay. So we take that 93 EF and all that, and we take the 37. The 37 was the first column on that prior page. Okay. We take the first column and the SubByte, which is the 93 EF AE, and we XOR them together. Then we take that result and XOR it with this value to come up the first column with a round key. Now, how does that actually work? I'm going to show you. Well, 37, you got to convert it to binary. Okay? So 37, I give you the values on the left side. You get 3 and then 7. So far, so good? Then you get 93. So we're XORing 37 and 93 together. Does everybody see where we got 37, how we converted it to binary? Everybody see 93, how we converted it to binary? It's just off the chart. Okay? So we XOR them together. XOR means one or the other, but not both. So starting from the left, we're going to get a 1, a 0, a 1, 0, 0, 1, 0, 0. One or the other, but not both. That's how XOR works. So when we XOR them together, That's what we get. Get one or the other, but not both. So we took the 37 and the 93, we XORed them together and got that result. Now we need to XOR that with 0, 1. So we put in 0, 1. Is that going to change our value at any? Only, well, it's going to change the last bit only. The last bit. So it changes the last bit. Now, stop here for a second. After we do the first row, when we get to the second, third, and fourth row, do we have to do the last XOR? Because we're XORing the last 3 with all zeros, correct? Yeah. So we really don't have to do the last one. Just so you know that, okay? Because it's a waste of time. Now, what would that be converting it back to a hex value? Anybody?
A.
Right, 1010 is A. Then 0101 is 5, so it's A5. So we take that value, A5, and there it goes. It goes into that block. Okay? So what's the next step going to be, you think? Right, do 89 and F. XOR those together. You can skip the 00 part because they're easy. Then get that result goes in the second block. I don't know if I walk through each one of these. I might. Okay, I just give it to you. It's 66. Now, I had an issue over the years. People tried to do the homework and they're consistently wrong. I mean, sir, people just doing it wrong. If you walk through this, I mean, figure out how we got to 66. Make sure you can duplicate this. Because if you can't duplicate this, then your homework's obviously going to be wrong. But so many people turn in wrong homework. I'm like, did you try the sample? I mean, we give you a sample here. If the sample works, then at least you know the technique. Okay? And the same was 91 and 12. That gives us the first column of the round key. Okay, so there we go. So what we did was we took the fourth column, the 8822, we rotated it. Remember that? Ran it through the S box. Then we took the first column and the result from the S box, XORed them with the archon, the 01 stuff, and put that into the first column of our round key. Okay? All right, so we took first column. So now we're going to bring down the second column. Now, you only run the first column through that whole archon thing, through the S box and all that. Okay? Now, you just XOR them together. So you only have to do the first one through the X box and do that stuff, okay? So now we're taking the second column of the first and of the cipher key and the first column we already created, XOR those together to get the final column, the final result. Watch where that goes. That goes back in there. That goes back in there. Okay? Now we take the third column, XOR with that. That goes back up. Column 2 goes back up. That one comes over. Take the fourth column, XOR with that. Okay, that goes up there. That goes up there. Then this becomes our fourth column. Okay? Everybody see that? That's why I gave you the PowerPoint, so you can see exactly where everything goes. Okay, we didn't walk through each of the values, but you saw how to at least create a portion of that. So far, so good? This is the easy part. Okay. Now, I have a Java program to do all this. It's all done but the Gloys field. I wouldn't mind sharing it with y'all if someone wanted to work on it, but if you're not going to do anything with it, don't ask me for it. Okay. If you actually want to play with it, I'll give it to you. That's not a problem. Okay. All right. So there's that part. So our cipher key became our round key. So far, so good? And the round key, so what we did is we created this round key. And the round key is brought in way at the bottom. So this round key is actually brought in from the top. And the way I grade this, by the way, I'm pretty sure there's 84 values. Let me an example here. For instance, state 3, I grade state 3. But then you notice state 3 is carried down. So if you got something wrong on state 3, I only take off for it once. I'm not going to take off -1 up there and -1 down here. So if it's brought down, like state 2, you see state 2 is actually created up here. So if you missed 1 on state 2, you miss a 1, but I don't take off for it again down here on state 2. But if you miss something on state 2, it's going to affect state 3. So really that -1 up there could affect state 3. Everybody with me? Kind of? Okay. So far we created the round key. All right? Hopefully everybody got that. All right. Now we have our encrypted text, our cipher key, and basically our initial round. Let's see how all this works. We take our encrypted text plus our cipher key to get our new state. I think I walked through this, don't I? Yeah, no, I don't. Okay. But it's the same thing. You XORing 8537 to get B2. 1D 89 to get 94. The same thing. Okay. Nothing different there. Okay. So far, so good? Okay. Now, SubBytes. We take this block here, run it through the second, or the S box again. Can I provide you with that? And you get that result. You take the B2 and end up with 37 and so on and so forth. Okay? Yes? No? Okay. Nothing new there. Okay. Now let's do ShiftRows. ShiftRows, we don't shift the top row, but we shift the second row by 1, third row by 2, fourth row by 3. Nothing different there. So we take the first row over, no shift at all. The second row we shift it by 1. Come on. So you see the 22 was at the beginning, it wrapped to the end. So the next one down, it will be 3F, 7B, 3C, 61. Okay? Because we're shifting it by 2. Okay? The next one's going to be 6C, AF, 27BE. Everybody see that? We're shifting it by 3. We're just moving stuff around, all it is. Okay. Now the hard part. This is the part that's on the test. Now on your homework, let me get to that part. You'll notice I'm giving you everything but the right-hand row. Everybody see that? It's imperative you know how to get the rest of those. Because so many people just focus on the right-hand row. But if you don't know how to do the other ones, I mean, you don't know the technique behind it. And remember, I gave you this instruction sheet. So really, all you have to do is MM, NN, OO, and PP. And they're right here. So it's M times 1. So it's M times 1. XOR N times 2. XOR O times 3. And P times 4. Okay, that gives you MM. Everybody see how to read that? But make sure you know how to do the rest, because you have to do something different on the test. Just know how, it's the same area. So make sure you know how I got, see, a lot of these I give you just a little, less the answer, but this one I gave you more, because it is a lot of work. Okay. So now let's see how to do that. Okay, so the mixed column process. Okay, is anyone doing algebra where they're actually doing this, or is there discrete math? Which class is it? It's one of the classes. I can't remember which one it is. I think it's discrete math you do it. Okay, you take the left column, multiply times the top row. Okay, so let's see what that would do for us. So the left column, so A times 1, okay, XOR B times 2, C times 3, D times 4 give us what? AA. So, this left column times the top row. So 37 times 01, 49 times 03, 3F times 01, 6C times 01. They're each XORed together. Gives us the top left block. Everybody okay with that? It's tedious, but it's not difficult stuff at all. Okay? So let's see how this actually works. Okay? Then you do that same row, let me go back to this page again. Now you see you're using A times 5, B times 6. So remember the first one you did this left column, top row gives us AA. Okay? Now left column, second row gives us BB. The left column, third row gives us CC. Left column, fourth row gives us DD. Are we okay with that? So, go ahead.
How is the A1 becoming? Are you going to get into?
Oh yeah, I'm going to do how the multiplication works. Yes, and that's very critical. I'm just showing you right now where. Where does the answer go once we?
Gotcha.
Yeah, I will show you that part. But the left column times the top row becomes the top left block. Left column times the second row becomes the second left block. Left column, third row, third left block. Left column, fourth row, fourth left block. Second column, top row becomes EE. Second column, second row becomes FF. Second column, third row becomes GG, so on and so forth. So fourth column, top row becomes what? So the MNOP in 1, 2, 3, 4 becomes what? MM. Okay. Left column, 5, 6, 7, 8 becomes NN. I'm sorry, right column. I meant left. I meant right. I said left. But right column, so MNOP 9, 10, 11, 12 becomes OO. MNOP 13, 14, 15, 16 become PP. Said PP. It's not good. Okay. But remember, for the homework, you only have to do that final part. But you need to know how to do it. Because if you come to me multiple times with getting that wrong, I'm like, did you at least walk through the rest of them? Okay? So now let's continue on how we do it. So basically, I just went through all that. I gave you that instruction sheet because that was a little confusing. Okay, then second row times top, second, so on and so forth. Third row, fourth row. Everybody okay on where they go? Not how to do it yet, just where they go. All right. Now let's get into the most confusing part of this whole entire lecture. We lost our clock. Someone stole our clock. Oh, those darn people. All right. Now. You have this. I don't know. There's a word for it. I can't think of the word for it. But if we were to take a number, let's get one here, like 37, okay, times that. Okay, remember we want to do the left column times the top row. Okay? How do we do it? Well, it's 37 times 2, 49 times 3, 3f times 1, 6f times 1. Okay? That's what we do. And that gives us the top left. How does this work? Well, you convert 37 into binary. Okay, I gave you the chart a couple slides ago. So you take 37 into binary. Okay?
Is that always the same number? 0, 2, 0, 3?
Yes, those are hard-coded. Yeah, that's in the matrix itself. The 0, 2, 0, 3, actually, let me go back a little bit here real quick. I can go back there again. That's from right there, the matrices. The matrix never changes. The values on the left side change. So if your state 3 is this. So state 3 changes. So obviously the left side changes, but the matrices never change. The values, the O2, O3, O1, but you'll notice they change inside the system. Remember some of the flaws of DES was hard-coded values? Well, we still have hard-coded stuff here. But it's based on a better math function. Okay, let's continue on here. So we got 37, we got 2. Okay? Now 37, okay. So we take 37, remember it's 00110111. And if we put that under our values, see our values at the top there? If we put that, so what we get is, why don't we have an x to the 7th? They want to know why?
0.
Because it's a 0. So we have 0x to the 7s, 0x to the 6s. We have 1x to the 5th, 1x to the 4th, 0x to the 3rds. We have an x to the 2nd, an x, and a 1. Everybody see that? So we literally just took the binary of 37, put it under the math at the top, and that's what we got. So we converted 37 into, I can't think of what the heck the name of that is. Then we take 2 and do the same thing. 0, 2 is all zeros, then 0, 0, 1, 0. All we end up with is an x. Everybody see how we got 2? Now we multiply them. Algebra. This all this is algebra. Okay? So it's multiplying. Okay? So it's x to the 5th plus x to the 4th plus x squared plus x plus 1 times x. Thinking back to math days, x to the 5th times x gives us x to the 6th. X to the 4th times x is x to the 5th, and so on and so forth. X times x is x squared, and 1 times x is x. Are we okay with that? So far, so good? Okay. So we took 37, multiplied it times 2, and got x to the 6th plus x to the 5th plus x to the 3rd plus x squared plus x. And what do you think we could do with that?
Go back to binary.
Right, we could put it back up at the top, and we would end up with a 0, 1, 1, 0, 1, 1, 1, 0. Everybody see that? So we can take that, and it's 0, 1, 1, 0, 1, 1, 1, 0, which happens to be 6e.
Is the word you're looking for binary expansion?
No, there's another. What's this whole math thing called? I can't think of it. It's not a quadratic equation.
Oh, that was the first thing you came to.
What is it?
No, what you said would have been probably the first thing I came to.
Polynomial? I can't remember that. I've slept like 27 years since I had algebra. But everybody see how we took 37 times 2 and got 6e? Yes, hopefully, maybe. So now we need to do the same thing with 49. Okay, 49, 0, 3. Everybody see how 49 becomes x to the 6th plus x to the 3rd plus 1? Okay, remember it's 0x to the 7s, 1x to the 6th, 0x to the 5, 0x to the 4, 1x to the 3rd, plus 0x squared plus 0x plus 1. So 49 becomes x to the 6th plus x to the 3rd plus 1. And 0, 3 becomes 1, 1, which becomes x plus 1. So now let's multiply this one out. So x to the 6th, x to the 3rd plus 1 times x plus 1 gives us x to the 7th plus x to the 4th. Then we brought 6 and the 3 up by 1. Then the 1 becomes x. So this 1 right here, 1 times x, gives us this x. Everybody see that? Now we got to do this guy. We just finished this guy. Now we're on this guy. So now we got to add the plus x to the 6th plus x to the 3rd. 1 times 1 is 1. So now we have x to the 7th, x to the 4th, x to the 6th, x to the 3rd, and 1. So far, so good. Put them in order, and that's what we get. Okay? That comes out to be 1101, 1011, or dB. Everybody see that? Okay. Whew. Okay. So now, we do 3F and 0, 1. That's the next grouping. Okay? Now 3F, that's what it turns into. It's like a polynomial. Whatever that algebra phrase is, that's what it is. I need to go ask Ann next door to ask her. Okay. Is it quadratic equation? Something like that. Something they talk about in the other building. All right. Yeah, FOIL. You know what sucked was I got an A in algebra, but I don't use it anymore. It sucks. Okay.
Sure you are.
Yeah, not really. I mean, if I had this part, I'd be good. Okay. So we got the 3F becomes, we have 0x to the 7th, 0x to the 6th, we have an x to the 5th, an x to the 4th, an x to the 3rd, squared x and 1. Okay? Now we're going to multiply that times 1. Now here's where it gets very difficult. So if we take that number times 1, what do we get? The same number. Okay? So if you're doing this, and any number that has to be multiplied times 1 is, guess what? Itself. Any number times 1 is itself anyway. Okay? So just remember that. Okay? So 3f times 1 is 3f. Okay? Easy enough, hopefully. Naturally, I don't give you that on the test, but, for homework you might have. Okay, now we do the next one. 6c and 6c. 6c and 0, 1. So there's 6. We have 0x to the 7th, an x to the 6th, an x to the 5th. Can you make it, Roger? Oh, okay. All right. Then we have 0x to the 4th. Then we have an x to the 3rd and an x squared, 0 x's and 0 1's. So 6c becomes x6, x5, x3, and x2 times 1, which obviously will become the same value again. Okay, so nothing different there. All right.
Binomial multiplication.
Is that what it's called?
Yeah.
Ah, good. It's binomial multiplication. See, we're doing some cool stuff. All right. So that's what we just did. We took the 3749 3f 6c times that top row. Okay? Come on. Took that times that top row. Okay, so we ended up with 6c, db, 3f, and 6c. We did all those. Remember that? Now we have to XOR them all together. Remember, we did the values. Now we get to XOR them all together. Ends up E6. Okay, we're not going to walk through them all. But that's what they end up being. You can XOR them yourself. We did that a couple times already. So where does the E6 go? Top left corner. Okay. It goes right into this dude right here. Okay. Oh, look at that. Okay. All right. By magic, with the click of one button, you complete the entire rest of the page. Isn't that nice? See how easy that is? Well, not quite that easy. Okay, we're not done. There's something called the Glois field. I will tell you this. If you need this on the test, I will provide it to you. Okay? If you need it on the test, it will be on the test. I'm not that mean. Okay. So what if we have E7 and 0, 3? This is just an example here. Okay. So E7, you agree that E7 is x to the 7th, x to the 6th, x to the 5th, x squared, x and 1. Everybody see that? We're missing x to the 4th and x to the 3rd. Okay? Then we have 3. So 3 is x and 1. Nothing new so far. It's all the same. Well, let's multiply them out. So if we have x to the 7th, 6, 5, 2, x and 1 times x to the 1, what's the result? X to the 8th plus x to the 7th plus x to the 6th plus x to the 3rd squared x, and that's it for the moment. But remember our little table there at the top only went up to x to the 7th? It's too big. So my point is, when you're doing this stuff and the numbers are too big, in other words, if you end up with an x to the 8th, you need the Glois field. Okay, and I'm going to show you what to do with it. So if you do your multiplications and you end up with anything larger than an x to the 7th, you must use this. Okay? Now we bring in our 1, so we take that times the 1, and we end up with that. Okay, so now, when you multiply E7 times 0, 3, you end up with that big old long thing, the red and the blue. Okay? So what do we do with it? Well, first thing you do is cancel out. So wipe out the x to the 7s, wipe out the x to the 6. If you got 2 of anything, wipe them out. Okay? So we end up with x to the 8th plus x to the 5th plus x to the 3rd plus 1. Everybody see that? That's what you end up with right there. Okay? So then take the value in green, XOR it with Glois field. So remember, we only need this when our math gives us something larger than an x to the 7th. Everybody see that? All right. So when we XOR those together, convert them to binary, okay? Because they're too big. Remember, we can only go 1 through x to the 7th. We can't do 8. And since we're using it with the Glois field and we're using XOR, the 1 and the 1s are going to cancel each other out. Everybody see that? This is a hard-coded value you need to use. So if we write these down here, it becomes that, which is x to the 5th, 4th, and x, I think. It goes 32, okay. I guess we just write 32 in there, okay. But everybody see how that works? If you ever do this, and your result is larger than x to the 7th, you get rid of your duplicates, use the Glois field, XOR with the x to the 8th, 4th, 3, x, and 1, then that's the result. Okay? Yes, sir?
Are you dropping the x to the 8th on that to get 32?
Yeah, we dropped the x to the 8th because if you look at the XOR, remember it's one or the other but not both. So we end up with 0. So what happens is, this first column, one or the other but not both, since we're XORing right here. So one or the other, these are the same, so that becomes a 0. That becomes a 0. Oh, I see what you're saying. Hold on a minute. We're missing something. Oh, it's just that they're separated apart. That's all. Because remember, it's the right 4 and then the next 4. So we dropped that last 0 off. Yeah, because it's only 4 bits and 4 bits.
So if there ever ended up being a 1...
It couldn't be, because that's the whole point of the Glois field, because it's got an 8, x to the 8th. And if you end up with an 8, and you XOR it with an 8, the 1 and the 1 are going to cancel each other out, and you end up with 0, 0, 1, 1, 0, 0, 1, 0. 0, 0, 1, 1 is 3, 0, 0, 1, 0 is 2. Okay? So far, so good? So that becomes 32. All right. Now, the initial round. Okay. So we take that value, XOR them, and get the right-hand value again. E6, A5, get 43, so on and so forth.
Where's 32?
Well, that was just an example.
Oh, okay.
Actually, it was... Actually, I think... Hold on, let me go back a couple. It should have been, I think it was one of the answers on this. No, it wasn't. It was just an example. Okay. Yeah. You need it on your homework. So we just came up when we required it. Yeah, because 32 is not on this one. I couldn't remember if it was or not. Yeah, that was just an example of what to do. Okay? All right, so we XOR these together, get that value. Nothing really special there. So that was the state we created after the mixed columns. We brought down the round key we created at the very beginning. Remember we created that round key where we shifted it over and did the archon and all that. And that gave us our ciphertext. And then we're done. So it's not difficult. It's just a bunch of little steps. Okay? All right. You know what? I don't want to stop you. Hold on. I got to find something here real quick. I want to show you this little video. Actually, can I pause this somehow? I'm going to try to pause this for a second. If I can find it. Is there not a pause? Come on. There's no pause in here? All right. Well, I guess you're all going to see all my top secret stuff. Oops. Yeah, the Sunday before Thanksgiving.
That's the 24th.
It's due the 24th. I'm leaving early on the 22nd for New Orleans. So if you want help, you need to get it by early on the 21st.
So inside the Dropbox, it has Dewey on the 24th. Is it different?
Oh, that one's going to be due as well.
Okay, so it's 2.
But I'm currently, right, there's going to be 2. This one I'm not making due for 2 weeks because it's a little more difficult. But Diffie-Hellman's going to be due at the same time. I want to go find something real quick. Where the heck is it? Aha.
Are we close to the final as far as test ones?
What now?
Are we doing one more test before the final?
Yeah, one more test. No, one more test is the final.
Okay.
Yeah. All right, I'm going to walk through this. It's a flash video. And we'll do Control F. Okay. This is the original cipher. Okay, I can post this up online if you want. Okay, this is how it works. Okay. Take our state, and the funny thing is, this is what Raymond used to create the PowerPoint. Okay. So the encryption process to the key, and this is the one I'm having you guys do, the encryption process. Okay, it goes through however many rounds. In this case, 9 rounds through SubBytes, and you're done. Okay. Now let's talk about the different transformation phases. SubBytes. You go through there. FID4. So on and so forth, and they all go in there. And okay. Then we have the ShiftRows. Remember, we rotate over 2, rotate over 3. Okay. Then we mix columns. And to put that, I think I explained it a tad bit better than this. Okay. That's your mixed columns. And add round key, which is the very ending part. And that's the steps you have to do. Does it 9 more times. The last one does not use a mixed column. And I'm only making you guys go through round 1, but it actually goes through many times. And then you end up with your ciphertext. Okay? Then the key schedule you guys are not doing. No, actually, you know, we did a portion of it, but that's right. We made the round key. Yes, we did. We made the round key. We used the archon one time. The archon's there at the bottom. Let's see, we shift it up by 1. And we do SubBytes with it. And remember, we brought in the archon of 1 right there. Get that value. Then the second one, we do not use the archon for the rest of them. Yeah, because we did this portion. This is creating our round key. Yeah, I remember we did this one now. SubBytes. Then we XOR those. Then we brought down the next column. Then the next column. We just did this at the very beginning rather than at the end of the process. Okay. Yeah, you guys only created 1 round key. So. Alright. But you notice the key changes per round. And that is it. So, what do you think? The Flash or the PowerPoint? Which one was easier to understand? Think so? I would hope so. All right. Now, again, if you go up to WordPress, let me show you where they're at. If you go to wordpress.rose.edu and go to Business Division, go down to this course, you'll see multiple versions of AES. Like, there's RSA. Come on, where's AES? Keyspace. RSA. There's AES right there. There's a recording right there. That's. Oh, come on. I know they're in here more.
Right
There
there.
it is. AES. No, that's the assignments. That's the assignment. It's got to be an easy way to find it. But it is up here multiple times. You just have to look for it. There should actually be 3 years of them. But yeah, you can go up there and find the old. But I will post this one up there as well. But they're all there. Using encryption manually. There's AES. It's actually the recording of it. You can play the. It's a recording of the PowerPoint. Okay. It should be up there again. If you can't find it more than that one time, I can put it up there for you. Cause I have all of them. I might have taken them down. Yeah, I don't see them currently up there. But that's, when was this one made? It was up April of last year. So it was last spring. But yeah, it wouldn't hurt. So. All right, let me stop this recording.